Image to image turbo. Imagine you have a picture of a beautiful sunset, but it was captured on a cloudy day. Wouldn't it be amazing if you could simply tell your computer, make it a clear night sky? And poof, your wish is granted. Or wouldn't it be a great, even if you are not good at drawing, and with just a single tool? Every ugly thing you draw could become an incredible masterpiece. This is the kind of magic that Image to Image Turbo aspires to bring to the world of image editing. With an MIT license code, it introduces two powerful models, Cycle GAN Turbo and Pix to Pix Turbo, that can completely transform images in only a single step. Yes, only one. But how does image to image translation usually happens? So let's see it together. Now we know the traditional image to image methods. Image to image translation tasks, they involve transforming an input image from one domain, that is grayscale, to another, that is color domain, while preserving the content. So these traditional methods for this task can be broadly categorized into two groups. First is the generative adversarial network and diffusion models. Now these GAN based methods like cycle GAN, they use two neural network, a generator and a discriminator. Now this generator will create images that resembles the target domain, while the discriminator attempts to distinguish real images from the target domain from this generated one. And through an adversarial training process, this generator progressively improves its ability to fool the discriminator, leading to a more realistic image translation. And this diffusion model, it takes a different approach. They begin with the noisy version of this target image and gradually remove the noise in a series of steps, effectively transforming it into a clean, realistic image. So while diffusion models excel at generating high fidelity images, they often require multiple steps, making them computationally expensive. So there must be certain limitations of this existing methods. So both GAN based and diffusion based methods have limitations that hinder their effectiveness in image to image translation. First is that GAN struggle to maintain the structural integrity of this input image during translation, which often introduces unrealistic artifacts and require multiple training stages and increases the computational cost. Then with the diffusion model, while they are adept at generating realistic images, they often lack the ability to precisely control the content of this output based on this specific requirements. Also, multi-step nature makes them computationally expensive for real-time images. Now comes this image to image turbo. So this image to image turbo, it addresses these limitations of traditional methods by introducing cycle GAN turbo and Pix to Pix turbo, which facilitates one-step image translation with superior content preservation and efficiency. These models leverage the power of pre-trained text to image diffusion model and integrate innovative architectural elements to achieve the breakdown. So this image to image turbo, basically it offers two distinct model configuration. First is a cycle GAN turbo and second is Pix to Pix turbo, which are tailored for specific image translation scenarios. So let's first understand what cycle GAN turbo. So this model, it excels at unpaired image translation, where the training data consists of an image set from both source and target domains, but they lack explicit one-to-one correspondence between images. For instance, cycle GAN turbo can effectively translate image from day to night or vice versa. Then this Pix to Pix turbo, well, this model caters to the paired image translation task, where the training data comprises image pairs with a clear correspondence between them. So this Pix to Pix turbo is adept at tasks like translating sketches into this photorealistic images or transforming edge maps into complete images, also by following the inserted textual prompts. So by leveraging the corresponding information from this paired training data, this Pix to Pix turbo achieves somewhat accurate image translations like shown here. So what is the core principle of this image to image turbo? So first is they have pre-trained diffusion models. Well, this image-to-image turbo models, they exploit the capabilities of this pre-trained text-to-image diffusion models like Stable Diffusion, which has arrived in its third version recently. And these models are adept at generating realistic images from text description. By incorporating a pre-trained diffusion model as a core component, this image-to-image turbo inherits its ability to produce high-quality images. Then is a single-step translation. So unlike traditional methods that require multiple stages, this image-to-image turbo, it achieves image translation in a single step, which reduces computational cost and enables faster inference times, making them suitable for real-time application. Then is the content control with text prompts. So users can still this image translation process by providing text prompts that describe the desired outcome. For instance, a prompt like daytime scene. It can transform an image from night scene to a day scene. So this text-based conditioning allows for precise control over the content of this translated images. Then preserving structural integrity. A key challenge in image translation is maintaining the structure of this original image. So this image to image turbo tackles these challenges through several architecture elements within its generator network. Now this image to image turbo generator will integrate three modules from this latent diffusion model into a single efficient network, and this streamlined architecture involves several features that contributes to its superior performance. First is the LoRa adapters. Well, these modules dynamically adjust the behavior of the network based on this text prompt. They essentially translate this high-level semantic information from text prompt into specific modifications within the network, which enables them to generate images that align with the desired content. Next, skip connection. Well, these connections directly copy information from the input image to later layers in the network, which ensures that crucial structural details from this input image are retained throughout the translation process, which results in a translated image that faithfully reflects the original scene layout. Then zero convolutions. Well, the convolution layers with weight initialization set to 0 are strategically incorporated into the network. And these layers play a crucial role in introducing new information relevant to the target domain without altering the existing structural features of this input image. For example, a zero convolutional layer might be used to introduce stars into an image when translating from day to night. Then retrained first layer, and this first layer of this unit architecture commonly used in image segmentation tasks is specifically retrained within this image to image turbo generator, and this retraining process allows the network to better capture the essential features of this input image, further enhancing the preservation of structural details during translation. Then trainable and frozen layers. Well, this generator network, it consists of both trainable and frozen layers. Trainable layers, which are depicted in say blue boxes, so they are updated. Frozen layers maintain the weight they acquired during the pre-training of this text to image diffusion model, and the selective training approach leverages the pre-trained knowledge while allowing for fine-tuning specific components for the image translation task. Then flexibility for diverse objectives. The image-to-image turbo architectures exhibits flexibility in accommodating various generative adversarial network objectives. And this versatility enables the model to be adapted to a wide range of image-to-image translation tasks beyond the examples provided in these research papers. Now, how it is a game changer for image editing. So, well, this image to image turbo project, it presents a significant advancement in the field of image to image translation. We know CycleCAN turbo and this Pix to Pix turbo, they offer various advantages. First is the superior image quality. So by leveraging this pre-trained text to image diffusion model, this image to image turbo models generate remarkably realistic and high fidelity images. Then they have exceptional efficiency. Because this single step translation process, it reduces this computational cost and which makes it suitable for real-time applications. Then the precise content control. So the text prompt empower users to steer the translation process and achieve the desired outcome, which fosters the creative image editing. And then structural integrity preservation. So the meticulous design of this generator network ensures that the structural elements of this input image are maintained during translation, which results in natural looking edits. And finally, its adaptability. So the ability to accommodate various GAN objectives, it broadens the applicability of image-to-image turbo models to diverse image translation tasks. And these capabilities makes image-to-image turbo a valuable tool for various applications, which may include creative image editing, photo enhancement, visual effects, image inpainting. You can try it yourself. This is available here at this link. So whenever you will apply, you can apply any sketch and you will find it out in a beautiful done image. So while this image to image turbo, it presents a groundbreaking approach to image editing, it's important to acknowledge that underlying technology, stable diffusion, is constantly evolving as large and improved diffusion models emerge. So this framework too can be readily adapted to leverage these advancements. So when are you going to try this? Thank you.